So now we're gonna proceed to demonstrate the execution of the hand gesture recognition. Hi everyone, so we're going to first look at the generate data.py file, which is the one used to collect the pictures for the hand gesture data set that later on is going to be trained. We start with executing generate data.py and pass two arguments. The first argument is the dataset path, and the second argument is the amount of pictures that are going to be collected. We proceed to add the needed imports for the program. Import sys to support attributes, import OS, import CV2 for opencV, and we import numpy as MP. And also we import a very useful library called PQDM, which will be used to show a progress bar in the terminal as the dataset is collected. So next we set a variable called directory, and take the first argument, which is the data path, and set image count as the second argument for the number of pictures that we want to take. So after setting the directories, we proceed with opencV and we set the video capture section with value of 0 for the laptop webcam. Create a variable called pbar, and this variable is created to be the one that works with the TQDM library, which is the one keeping track of the collection progress. So then we proceed to the loop, and while the loop is true and the count of images is less than the image count argument, we want to keep iterating the loop. So we update pbar for each iteration that we do. We increment the file count, which is using the file name variable, so that each photo has a different name, and we increment the count of the pictures taken. So then we proceed to read from the camera. We convert the images to grayscale. We set the directory, name of every picture, and set the pictures as .jpg. So we add a rectangle on the screen so that we know where to do the gestures as we collect the images. Input the images and resize them as 224 by 224, and then we use that AMRite to actually save the images in the path that was specified earlier. Actually, there was a pass on when we execute the program, and we save the pictures. So we use that show to have a video recording of what's happening, and basically that I'm just using the webcam camera, and in conjunction with the rectangle that we show on the screen, it's going to give us a very useful guide to know where we have to put our hand with the gesture that we want to collect at that specific moment. So we proceed to set a way to get out of the program, and that is by pressing Q. We close P bar, release the camera, and destroy all the windows created by the program. Okay, so now we're going to look at the training model.py that will generate the model that will be trained with the data set that we created earlier. As usual, we add all the necessary libraries to support the program, especially the one for TensorFlow and keras will be the tools used to make the training possible. We want to organize the data into folders named train, valid, and test that TensorFlow will use later to train the collected images. All the 10 collected gestures are going to be stored in the train folder. And for the valid and test folders, we create 10 folders ranging from 0 to 9. We then take samples from each folder ranging from 0 to 9 from the trained data set and distribute 10 random images in the test folder for each of the 10 folders. And then do the same for the valid directory, which will take 50 random images and store in each of the 10 folders. So then we set the data path, train, test, and valid folders and start the training process using the MobileNet model. So in the image data generator, we pass the MobileNet pre-processing function. So then set the directory to train path, resize the data to a height of 224 by 224 since the MobileNet specs that size. For the test path directory iterator, we include an argument called shuffle, which will be set to false since this is so that we can later attempt to plot the results to a confusion matrix. So then next we import the MobileNet model, and for fine-tuning the model I choose the first 6 layers, and this is just personal preference. This was the best outcome that I got, and basically fine-tuning the model is just finding the combination that works best for you. So we then create a variable called output and assign to a dense layer with 10 units. 10 units for 10 classes, 0 to 9, and a softmax activation function to give us the probability distribution among those 10 outputs. So the X included is the X is included since we're working with a functional model type, and the dense layer X is passing up to the 6th to the last layer in the MobileNet model. The MobileNet model is a functional model, so that comes from the functional API from keras. So next we call the model and pass the input from the original MobileNet model, and output being all of the MobileNet up to the 6th to the last plus the dense output layer. So we then can proceed to train the model using model.compile, and we're going to use the Atom optimizer, which is a stochastic gradient descent method that is based on adaptive estimation of first order and second order moments. So we use a loss categorical cross entropy, and as metric we're going to use accuracy. So we proceed with the model.fit in this section, and we pass many arguments that we're going to discuss next. So X for input data being train the batches. We pass steps per epochs, which is the total number of steps before declaring one epoch. Before declaring that one epoch finishes and starting the next epoch, which is a value of 18. So then we have validation data, which is the data on which we evaluate the loss of any model metrics at the end of each epoch. We have validation step, which is only relevant if validation data is provided, and total number of steps, and this is basically to draw before stopping when performing validation at the end of every epoch. And epochs is basically an iteration over the entire X and Y data provided, and just to have this in mind, the more epochs, the better the accuracy of the prediction is going to be, at least in my case. So last, for this function we have verbose, and verbose can be 0, 1, 2. Verbose 0 means silent, 1 progress bar, and 2 1 line per epoch, so we choose 2. And finally we can proceed to save the model on Calimine model myGestures.h5, and we can print on terminal just to assert that the model has been saved. So the last file that I'm going to use to achieve the prediction with gestures is webcam.py, and this is basically going to use opencV to use the camera so that we can use tensorflow and predict the hand gestures that we're going to use. So as usual, we import all the libraries that we're going to use for the program. We call the model, and we're going to add keras, and we're going to load our model, which is called myGestures.h5. We will print model successfully loaded, just assert that the model was loaded correctly. And then we continue to start to set up the video camera. So while the loop is through, we read from the camera, we set up a rectangle on the screen so that we know where to place the hand and proceed with the hand gesture. We resize the frame, and we then pretty much like pre-process the frame using the MobileNet model from TensorFlow is keras. So pretty much we proceed to predict the frame, create an array that pretty much containing all the 10 gestures, and we're gonna name them with 0, 1, 2, 3 all the way until 9, making 10 gestures. And pretty much I'm gonna put those names on the prediction, and I'm gonna use show to show everything that will be happening. We can terminate the program with Q, release the camera, and destroy all the windows.